Okay, let's start chapter 6 today. 6.1, I will be providing the Surajesh video. Okay, it's some exercise. It's quite easy. You can watch it from there if you have doubts. Now, but just to clear it up, the concept is this. What is the difference between similar triangles and concurrent triangles, or similar figure and concurrent figure? The difference is, if suppose, let's take an example of a triangle. Okay, if there's two triangles, we can say that this two triangle is similar if all the angles are same. Not all angles of a triangle, but all the corresponding angles of this triangle is same with this is same with this is same with this. It doesn't mean that the sides are same, okay? It just means that the angles are same. Okay, so the proportion also becomes same. For example, if this is 2, this is 4, this is 3, this is 6, this is 5, this will be automatic 10. Matlab to 2, if you divide these two sides, you will always get the same ratio. That's the meaning of similar. Okay, but concurrent literally means exact replica. Concurrent means exact replica, which means if this is 4, 4, 3, it has to be 3. 5, it has to be 5. It cannot be any other value. It has to be exactly the same. Even the angles. If this third angles, so for both it's same. Even for similar triangles, all the angles are same. Even for concurrent triangles, all the angles are same. Got it? So suppose I'm just writing, okay, Mr. Mishi. Everything has to be exactly the same. Here also angles are exactly the same, but then here the sides are not same. It's in proportion. It gives, if you divide this side and this side, this side and this side, this and this side, it always ends up in the same proportion. Okay, kata-kata pichire same babo. Next thing, in concurrent triangles, for example, we need at least 3 things to show that something is concurrent with this. That is, one side, one angle, and one side has to be same, or one angle, one side, one angle has to be same. Side is there, right? This is all for concurrent, okay? And the sign for concurrent is this. Similar is just this. There is no equal to in the bottom. So for similar triangles, there's only 2 ways to show. One is AA, which means if 2 angles are same. Suppose in this triangle, okay, let's say X, let's say these 2 triangles, suppose this is 70, okay, this is 70, this is 60, this is 60. If these 2 are same, we can already say that these 2 are similar. Why? Because the third angle will automatically become equal. In concurrent triangle, remember this, in concurrent triangle there is no AA. Angle tinta same holi concurrent ase no hoy. We cannot say it's concurrent, okay, unless one of the side has to be included for concurrent triangle. In similar triangle, as soon as we see 2 angles are equal, we can directly say it's similar, because 2 angles equal means the third angle 180 minus these 2 added up together would be 50. Here also 180 minus, so automatic third side angle will also become same. So 2 angles showing is enough for similar triangles. And then one side is proportional. Suppose we don't know this, okay, let's say we don't know these 2 figures, but we do know that, and this is, okay, let's do it here. There's 2 triangles. We know that this is 3, this is 6, this is 5, this is 10, and this is 30, and this is 30. We don't know this angle, we don't know this angle, this angle, this angle, or nor do we know the side. But we can say that these 2 is similar because 3 divided by 6 is 1 by 2, 5 divided by 10 is also 1 by 2, and in the middle the angle is 30 degrees equal. So it's SAS, but not this SAS, okay? This SAS means the 2 sides are exactly the same and the angle is also same. But here angle is same, but the sides are in proportion. That's what this is. So in similar triangles we do this, in concurrent triangles we do this. This is only for triangles, but concurrent means exact replica, similar means the same ratio. Okay, we're just enlarging it to the same ratio. So that's the basics of this similar triangles and congruent triangles. So before we start 6.2, please make sure you watch the video of 6.1 from, sorry, I'll upload it in Google Classroom. We will start by learning a theorem, which is extremely important, very extremely important. State and prove Thales theorem. That will be the question. You will have to memorize the statement. The statement says, if a line is drawn parallel to one side of a triangle. So this is the triangle, and to one side of a triangle I drew a line parallel, that is DE, to intersect the other two sides in distinct points. So intersecting AB at D, intersecting AC at E. Intersecting means it's just touching, okay? Touching AB at D and touching AC at E, okay? In distinct points, the other two sides are divided in the same ratio. The other two sides, which means AB and AC, is being divided in same ratio, which literally means that the question in the question, they're saying this is a direct triangle and there's a line parallel to this line. So DE is parallel to BC is given in the question. To prove, they're asking us to prove what? That other two sides are divided in the same ratio. So AD by DB equal to AE by EC is what we have to prove. Okay, AD by DB equal to AE by EC. First, we're going to do construction. For construction, just to we're going to do draw. We will take this thing, okay? Perpendicular. Perpendicular means what? Perpendicular means when you're drawing something 90 degrees to a line. Perpendicular means it's represented by this, okay? So if I draw, say, perpendicular, it means if there's a line and if I draw a 90 degree here, then this line is perpendicular to this line. That's what it literally means. So draw, let's say M and N, okay? DM perpendicular to AC. So first let's draw DM perpendicular to AC. 90 degree. 90 degree. So this is 90 degree, okay? DM perpendicular to AC. And EN perpendicular to, it was AC, now this side, AB. So this part, see, in exam they will not give you the diagram also, they will not give you the statement also, they will not give you given proof, nothing. They'll give only the state and proof tells you, so you have to memorize all this part. Okay, there's not a way out. So let's draw perpendicular from E. So this is 90. Okay. Now also join BE and DC. BE and DC. So let's join DC. And then let's join BE as well. Okay. Now, let us do up to this much is construction. Now proof. So this much you'll have to memorize, and then from here onwards you try to understand what's happening. Okay. After that you'll be able to do it if you understand. So first we're gonna take areas. Okay. Area of triangle ADE. I'm doing that. Let me show you what I'm doing. AE divided by area of triangle DEB equal to, see, or for ADE, okay, I'll draw AD here. ADE. This is the height, right? And so if this is the height, if we take this as the height, this becomes the base. Yes, so half into base into height. Okay, let's just write the formula first. Base into height, half into base into height, so we won't get confused. So half off we can cut. Now base in this case for ADE, base is what? AD, because since height is this, whatever the height is touching will become the base. So AD into height is what? NE. Now the tricky part is this for this triangle. For triangle DEB, for triangle DEB. So see this triangle DEB, I just drew it here, but what I'm gonna do is I'm gonna turn this so you can understand better. Okay, so if I draw a straight line here, okay, when you're calculating the height of a triangle, you don't count this one, you always count 90 degree. Okay, you always see the 90 degree from the highest point of the triangle to the floor, highest point to the floor. See, if you see the highest point, this is the highest point, right? Directly to the floor is the height, so this becomes the height. So in this case, if I reverse the diagram back, see this is the height, right? 90 degree. So if I reverse back to this, the height is what? NE. That's a 90 degree, right? So the height is, I hope you understood that. So height becomes NE, and the base, since we're talking about triangle BDE, this part is just imaginary line drawn so as to calculate the height. So the base, this is the original triangle, so the base is BD. So base is BD. NE we can cut, so we're getting, therefore area of ADE by area of DEB equal to AD by BD. Okay, so first what we did, we took this triangle and we took this triangle. Now again we're gonna take the other two triangles. Okay, area of AD, will take it again, but area of, first we took this, now we're gonna take this, the green part, so DEC. Okay, half into base into height, half into base into height, half we can cut. Now if I draw the same ADE, but this time what I'm gonna do is I'm gonna take the height as this one, because this is also 90 degree. See, ADE, this is the height. So if I take this as the height, whatever the height is touching, this becomes the base, so this becomes base. Got it or not? If I take DM as the height, AE will become the base, right? So in this case, base I'm taking as since height I'm taking as DM, the base will become AE. So DM divided by, now DEC, we'll do the same thing. Okay, for DEC, see, DEC, DE is here, I'm drawing this one again, DEC. See, now if I turn it like this and make it in the straight line, the 90 degree will come down here. And if I go back to the original diagram like this, the 90 degree is M. Got it? So the height will be DM. So the base is, see, this is triangle DEC, and the height is touching this line. So the base is, but the base, the actual measurement is from here to here only, so EC. EC is the base, so EC into height DM. So DM I can cut. Therefore, area of ADE by area of DEC equal to AE by EC. This will be your equation 1. This will be your equation 2. See, we are asked to prove AD by BD equal to AE by EC. So we somehow got AD by BD, we got AE by EC. So if somehow we can make this equal, that is ADE is also equal, but the only difference is this triangle DEB and triangle DEC. So we'll somehow try to show that triangle DBE and DCE are same. Okay, so let's try to do that now. Now, it's a theorem you should have learned in class 9, but I think it was deleted from syllabus, I suppose, last year. So you might not know, so I'll teach you now. If I draw a base, okay, I draw a line, and from this line I draw another parallel line. Let's say this. So this line and this line are parallel to each other. Let's say. Now, from this line, using this much, let's say this is 3 centimeter. This is infinity long, just parallel. This and this is parallel. Okay. So if this as the base, I draw any triangle. Okay, any triangle. Literally. Let's draw with other colors also. Like this also. Any triangle. Okay. I've already told you in a triangle, the height here, the height is always the highest point to the ground. So highest point to the ground. So the height of the red triangle will be this to the ground, highest point to the ground. The height of the green triangle will be this, highest point to the ground. The height of the blue triangle will be this, highest point to the ground. But since these two are parallel lines, the first one in this line, all these are same, right? The distance between this and this will always remain the same since it's parallel line. It'll never touch, and the distance between them will always be same. So which means if this is x, this will also be x, this will also be x. So the area of red triangle is half into base. Base is 3 centimeter into height is x. The area of green triangle is half into base is 3 centimeter, height is x. Area of blue triangle also half into base will be 3 centimeter only. Whatever the height is touching is the base, but its actual measurement is here, so that only, and the height is x. Since the distance between the two parallel lines will always be same. So what we can conclude is that all the areas, no matter how many triangles you draw, from the same base between two parallel lines, it will always be exactly same. The areas will always be same. So using that theorem, we can use that theorem and say that these two areas, because we needed, what did we need? Don't do the red mark. Okay? We needed triangle DEB and DEC to be equal. And if you observe carefully, DEB and DEC lie between the two same parallel line, that is DE and BC. And DE will be the same base. Let me show you here. Taking DE is the same base. DE, right? And DE is parallel to what? BC. And then this is a triangle, this, and then this is a triangle, another triangle. So these two triangles are using the same base and they're between the same parallel. If I draw the height, it'll be this. If I draw the height, it'll be this. The height will be same, the base is same, so area will also be same, right? So we don't have to show all the stuff. We just have to write. This is a theorem which you should have learned in class 9. So that's a class 9 theorem. So we can directly write, since triangle DEB and triangle EDC lie between the same base DE and between the same parallel line. Therefore, area of DEB is equal to area of DEC. So now that we showed that DEB equal to DEC from 1 and 2, ADE by DEB. So DEB direction, but DEB la jaga DEC likho paro. So if I write instead of DEB DEC, ADE by DEC, ADE by DEC na. So from 1 and 2 we can say AD by BD equal to AE by EC. And it's proved. I hope you understood. It's a very important question. If it comes, I think it will come for 3 marks. I think that you last year, class 9 also one theorem came, right? Final exam. So please first write the statement. And then write the remaining.